Welcome, everyone. Thank you for coming. Before we get started, I wanted to just get a quick poll of the room of who here actually works with Erlang on a daily basis, or all right, good majority. And what about Elixir? Okay, cool. And how many of you have already started with Phoenix? Okay, cool. So hopefully today, for those of you who have already started working with Phoenix, I might be able to show you something, but this is kind of an introductory to Phoenix. So hopefully along the way, I can teach you some insider kind of things that you can take away and have fun with. So. My name is Sonny Scroggin. I'm one of the core contributors to the Phoenix framework. And so before we get started, for those of you that don't know, Phoenix is a web framework, and it is built on top of the Erlang or the Elixir programming language, which of course rides on top of the Erlang virtual machine. So, and that's one of the things that's so great about Phoenix in particular, is that it just works with Erlang and the Erlang OTP protocols and stuff. So Erlang itself, as you all probably know already, is a functional programming language. It has immutable data by default, and it's actually the only way that you have data. And of course, has the awesome actor-based concurrency model. And it has a preemptive scheduler. So I know that a lot of people that work with Erlang work at it from the language level, but there's also the beam, the virtual machine underneath the hood is what's really, really incredible about this whole ecosystem. And so essentially, the beam is like an operating system for your code. You've got the kernel and the standard library and stuff like that. And then you've got OTP. And then you've got the language level stuff, which is Erlang and Elixir. And then you've got your code kind of all living within there. And then within that, you've got the beam itself has a scheduler for every single core that's on your machine. And this is really where what we all know and love about Erlang is that it works across all the cores on your machine, and so that you can take advantage of that. So each scheduler runs independently and has a run queue of all the processes in your machine. And of course, processes are how we interact with all of our different pieces in the system, and maintain state via recursion and things like that, communication through message passing. So all of these things are pretty much most of what we learned when we were learning Erlang or Elixir. But each process is actually really, really interesting. It has its own memory space, which has the stack and the heap and the mailbox, and then it's got links and monitors to all the other processes that it knows about and is linked to, and it has separate garbage collection. So, and what all that comes down to is really this. You have isolation and concurrency. So crashes are isolated. They don't take out other processes within the system unless they're supposed to, like when they're linked or something. And of course, data is isolated in each process, and garbage collection is handled independently. And the virtual machine, the scheduler, takes care of load balancing on I/O and CPU. And so you have this efficiency on multi-core systems. So, and of course, OTP makes all this work really nicely with supervision trees and all that kind of stuff. And so Phoenix itself is essentially an OTP application that allows you to, or it provides functionality for the OTP application that you're building. It's not something that you create and then it owns the whole world. It runs independently and can be stopped and started independently, as well as any other applications or OTP applications that you have running within the overall application that you're building. And that's really, really interesting and different from a lot of other things that you might be familiar with out there. And so it's, of course, Phoenix is there for you to write your kind of traditional HTTP stateless applications where you're doing request response cycles. And then we also have an amazing thing called channels, which is geared towards what the modern web looks like. And that is where you have stateful connections to the server and you maintain state between that. And you have a really nice message passing between the client and the server. So, as I said, Phoenix is an MVC framework. We have the MVC kind of model view controller that comes with most of the other web frameworks that are out there. So it should be very familiar to those with experience with frameworks like Rails or Django in Python. We also have channels for implementing soft real-time features. Out of the box, it comes with with support for WebSockets and long polling, but that can be adapted to use other technologies as well, and you can write nice backends for it. Phoenix is really easy to test. We come out of the box with a bunch of testing utilities and things that make it really easy to test things in isolation and to test the whole stack as well. And one of the things that's really, really, really nice, of course, about Phoenix is that it doesn't make you compromise, between performance and productivity. It gives you both. Many people who have experience with frameworks like Rails, for instance, know that you get really, really nice short-term productivity. It's really easy to get up and running and all that good stuff, but as time goes on, it becomes very, very hard to maintain that code over long periods of time. And then also, of course, with that, you might have high productivity in the beginning, but then when it comes time to scale your application, that's where the shit hits the fan. And you now have this hard problem with trying to scale the application. And of course, with Elixir, because of Erlang and the whole virtual machine, you really don't have to make that compromise. You get both. So with that, let's talk about performance. It's probably almost been about a year, maybe, since this benchmark has been taking place, but it still is pretty relevant. As you can see here, this guy here, the gist is at the bottom, went and took a bunch of different frameworks and different services and tested out each one and benchmarked them against each other. And what we find here is that Gin is a Go framework, I think, and Play is from Scala. We've got like Node.js with an Express cluster of machines, Martini, which is another Go framework, and then we've got Sinatra and Rails down here. And Phoenix was actually tested in 2 versions, and this is way before 1.0, which is pretty awesome. Phoenix is obviously here at the top, along with Plug. And Plug itself is not really a web framework, but it is a library that Phoenix rides on top of. And as you can see there, it is at the top of the pile against all of these other frameworks that are supposed to have like incredible speed. And so this is really telling of what we get. And as Chris mentioned earlier this morning about the story of going to 2 million connections, 2 million WebSocket connections across multiple clients, attaching to one machine. And this is really just incredible that you can have this kind of scalability and performance and efficiency in one single system. So let's talk about how to get started with Phoenix. Installation is really, really simple. We have a mix archive install where you can just provide this URL and it will install an archive for you and you'll have it accessible across your whole machine. And so then you can just use this command here, mixphoenix.new, my app, and it will go ahead and generate an application scaffolding for you, creating all the various files that you need to get started, configuration, your actual lib, and then the web stuff, as well as all of the testing utilities and some tests that will help you get started. It'll automatically fetch and install dependencies for you as well, including the front-end build tools for all of your JavaScript and CSS asset pipeline kind of stuff, and gets the dependencies. And then all you got to do is just change into that directory. You can run a command called mix-ecto.create, which will create the database for your application. And then you can start the server. So you can do that with mix-phoenix.server, or you can use IEX as well, which will put you into an interactive Elixir prompt that'll allow you to interact with your running machine. And with that, you have a nice, pretty landing page that gets you going, and the server logs as well. And one of the things you'll notice is that Phoenix generally will serve your pages if they're not going to the database and stuff like that very, very quickly. This is 230 microseconds. And later on in this talk, we'll get into some of the details of how that's possible. So Phoenix is built on top of some other really awesome libraries, and Plug is the main one. And it's just a simple abstraction for dealing with different web servers. And so the main web server that it runs with out of the box is Cowboy Web Server, which is written in Erlang. And of course, you can build other adapters for different servers like LE. I think there's some progress going on there for that. But it basically allows you to deal with any web server as long as it is adapted for Plug. So, and then we have also Ecto, which we won't talk too much about here in this talk, but it's basically a DSL for writing queries and interacting with the database, which we do a lot in kind of RESTful style applications. So probably one of the biggest things I want to talk about in this talk is Plug, because it's really such an integral part of what Phoenix is for the request response stuff. So, and essentially is a specification for writing composable modules or functions for dealing with the whole web request and response. And so what you get with that is you have just simple functions or modules that have a specific, they export a couple of different functions, and you can use them for anything throughout the stack. And the contract is really, really simple. It just receives the connection as the first argument and some options, and it just needs to return the connection. And so you make these simple, tiny little transformations of this connection data structure throughout the life cycle of the request. And that is really, really simple to follow because it becomes just kind of like a pipeline of function calls. So as I said, the plug specification, there's two types of plugs. There's function plugs and there are module plugs. So function plugs is essentially just a single function that has those two arguments, the first being the connection, and the second is some options. And this is the type signature that you would find in Elixir. And here's an example of such plug. This one would be for adding the content type of application JSON to the response, for instance. So you would use, you'd write your function here, JSON header plug, takes in the con, which is the connection, and then the options. In this case, we don't really care what it is. It's going to be like an empty list for the most part, but it could be anything that you want. And we just take this con and we pipe it into this put response content type, which is also a plug that comes from the plug library itself. And we're just telling it, go ahead and put in content type application JSON for the response header. So the next thing is module plugs. And module plugs are basically an extension to the function plug. You need just to export two functions in your module, init1 and call2. So init1 just takes a set of options and it just needs to return those options. So maybe you do some transformation of those options to kind of initialize it, and then you just return those. And those options are then passed in as the second argument to call2. And of course, call2 takes in the connection as the first argument, and it just needs to return the connection. And the interesting thing about this is that init1, it can actually be a compile time optimization. So at compile time, init1 could, whatever it returns is kind of cached into the file. So you don't have to, it doesn't have to be executed each time it's called. So, and here is an example of that JSON plug, but just in a module. So we're just doing init1, returning the options, and call2. We're doing the same thing as before. And so this is probably hard for you to see in the back, but it just is the plug.con data structure. And this is that simple data structure that is the connection that's piped through your entire stack. And this is what I love about plug, because it's just the single source of where you need to worry about the state of your request. It has fields in here for dealing with the request, the response, and different things in there. And so you don't have to have, in object-oriented systems, you might have several different objects that have to coordinate to actually take in the request and then do some parsing and then have to actually end up spitting out the result. So as I said, this comes from the plug documentation, and the plug documentation is pretty fantastic. It actually explains every single field that's in here and gives you an explanation of what they are supposed to be there for. So we have request fields, fetchable fields. Fetchable fields is pretty interesting too, because there are certain times where you may not care about parsing cookies, for instance, or query string parameters and things like that. And so these fields are not actually fetched and parsed until you want to or you need to. So you can save some computation time there. And then, of course, there's the response fields, which contains the body, the status, headers, and things like that. And then connection fields. So the connection fields, the main one here that's used is the assigns, and that is for you to store different values into the connection that you need to use throughout the life cycle of the connection. Maybe you grab a user from the database and you would store that in the connection so that you can have access to it later on in the life cycle. So, so in Phoenix, we have 3 plugs. There's the endpoint, the router, and controllers. So the endpoint is essentially the place in your application that sets up the initial plug pipeline. And this is for every single request that comes through the system. Every plug that's set up in the endpoint will always be run. And this is also at the end where it fires off for the router. But overall, this is the kind of boundary of the application. This is where all the requests will start from. And so this is the kind of the endpoint module that you have. This is what's really cool about this approach. For instance, in Rails, it's very difficult for you to kind of have access to making sure, like all the different middleware that you might have running in your application. You don't always have access to making sure that things are executed in certain orders or things like that, and you have to really kind of hack it through, configuration and when the application is initialized. And we made this very explicit through the endpoint. You have to kind of plug every single thing that you want to do. And these are the ones that are generated for you automatically, but you can customize each thing. You can take stuff out that you don't need. You can put stuff in that you want extra to happen on every single request. And this just makes it very explicit, very easy to reason about what's actually going on in your application. So we have this first thing here is the socket, which is for the WebSocket stuff that we'll get into later. But we have plug static, which will handle static assets for like CSS and JavaScript and things like that. We also have a section for when you're in development that you can turn on code reloading and live reload. So as you're developing, you make changes to different files, it'll automatically reload the browser for you. It'll automatically recompile your code and make those changes for you. And we also have plug parsers, which is used for parsing the different pieces of the request. So if you have some query string parameters, it'll parse the query string, it'll parse multi-part forms, and then there's also a JSON parser, which will parse the JSON body. We've also got a few other plugs here that are some nice things that I won't get into right now, but we've got plugs for session to set up your cookies and all that good stuff. And then the final thing that we do is we plug the router, which is the next plug that we'll talk about. So the router provides some nice macros that you can use that map really well to HTTP verbs. So get, put, patch, post, delete, and so forth. And these basically allow you to match on the URL and dispatch that to a module that will handle that action. So, and so this is just a very simple router here. We've got the scope, which basically allows everything in the top level scope to be matched on here. And then we just have like this get to slash goes to the page controller, which is a module. And the index is the action or the function that's going to be called within that module. We also have this nice thing called resources. And resources will automatically set up kind of the 7 RESTful routes that you would normally have if you're familiar with Rails. It's very similar. So what's really nice about Elixir is the macros that allow you to build DSLs that make sense for stuff like this, building nice UIs or nice stuff like this. So. And what that actually does, so if you look at this, like resources, rooms, and users, it's all nested here. What this actually does is that when at compile time, it takes these macros and it generates a match function. They're all named match, and they all just have different patterns here. And so we at runtime, we just use the beams pattern matching to pick the right function and route it that way. And it's incredibly fast to do it this way, whereas other frameworks have to route based off regular expressions and stuff like that. They spend a lot of time actually trying to dispatch what function, which handler do I invoke. So in this way, the beam does all the work for us. And so for each one of these, the connection from plug is the first argument that's passed in. And then the rest is all matched on the request. So something like this, and this here is just the function heads. So the next thing here is to show you exactly what it looks like in the bodies of those functions too. So something like get slash to page controller ends up compiling into this. And so we put some private information inside the connection, namespaced under the Phoenix namespace. And we're just basically setting up the controller to handle the action and piping that through. We've got some nice mix tasks that you can run. So mix phoenix.routes will then print out and show you all the routes that you have based on your current router config. And it'll show you all the modules and functions it'll send to. So pipelines are obviously been around for a long time. In the 70s, we all know it when we use Unix, for instance. And of course, this allows you to kind of put common functionality together. And this is what a lot of times we have to write in certain programming languages, where you end up taking an argument and you have to kind of wrap it, and it's really difficult to parse exactly what's going on there because you have to read it inside out. And so in Erlang we see this a lot, where you know, got your function, and you've got your con, and now you've got con1, and that goes to the endpoint that gets returned, and so forth. And you kind of have to add these new you know, numbers to each one because you can't rebind. And so the problem with this, of course, as those of you who have programmed in Erlang know, is if you want to add something in the middle here, then you end up having to rename all of your variables, and it's very easy to cause a bug, probably, right? So, so we want something more similar to this, where the output from something on the left goes into the input on the right. And that's what we get with Elixir with the pipe operator. So this is much easier to understand what exactly is going on. And this is what plug does. It essentially gives you a pipeline of functions to pass in this data structure, and you just perform these tiny transformations, each returning the connection each time, and it just pipes it through to the end of your program. So start off with getting the connection from parsing the request, send it into the endpoint plug, which then sends it into all the plugs that it has in there, goes through the router, and then your controller, and then finally you will send the response. So, and looking at it like this, you essentially are taking a string from the HTTP request, doing all the parsing and processing, and then just spitting out a new string. So another thing that is nice in the router is router pipelines. Pipelines allow you to take that, like I said, that common functionality and group it together. So if you have like HTML that you're HTML website that you're doing, you might have some things that you care about that happen on every single request. And so you can create like a browser pipeline that allows you to set up the session, for instance. You might want to fetch the session from the cookie, find whoever's the current user. You might want to set up some extra headers for protecting from browser attacks and things like that. And so that's what you do in the router. In the scope here, you can just set up pipe through and pipe it through the browser, which will then go through and after it figures out which route it's going to go to, it will dispatch through this function first before it invokes a controller. So the other thing we have is generators. And generators allow you to kind of scaffold out ideas, and really we use them for learning tools for people that are just getting started. It will generate all the code for you that you need in order to get a simple CRUD application going. And then you can take that and look at the code and learn from it. So obviously it comes with kind of the standard best practices that we've made for you and allows you to get going really quickly. So showing you this here real quick, you can, creating a blog, for instance, you would use Phoenix gen.html to generate an HTML resource with like HTML views and things like that. You give it the name of the model, which would be post, which is a singularized thing. Posts, plural, which will be usually the resource route on your website or on the URL. And it will also usually map to the same, like the table name that you'll use in your database. And then you can give it some columns. So we have a title, which is a string, and we have text for body. And that will then generate all the files for you and give you some instructions at the bottom to proceed. So it just says, hey, stick this in your router, and then go ahead and migrate your database. So we stick that in the router, and we run mix-ecto.migrate, and that ends up creating the table in the database. And then when you visit the URL now for /posts, you see an empty table here. You can click the new post button, and it'll give you a new form to type in your title and your body. If you try to submit it without any text in there, it'll tell you, hey, you gotta to fix some stuff here. You got these fields can't be blank. You correct it, resubmit, and you get a post created. So, and of course from here you can show, edit, delete, etc. So, all right. So controllers. This is where you're basically going to do all of your business logic for taking in the request and making stuff happen. So controllers also have pipelines as well. So you just say plug, and you can give it the name of a function or a module, for instance. And then you can also have these execute conditionally as well. So you can say when the action, which would be the action, the function name that's going to be called, is in create or update, for instance. So this allows you to ensure that functionality is happening on certain actions all the time. So just quickly, we have the index action, which is generally when you go to /posts, you will then fetch all the stuff from the database and display it out to the users. You have the show action, which will be /post/id, which will just get a single record. The new, which will generate a form and show you, give you the fields to create a new one. If you do a post to /posts, then it will then take the form elements and create a new post and save it into the database, and so forth. So you've got the edit action, which is very similar to the new, and you've got put or patch for similar to the create, but you're doing a put and patch to the posts with the ID, and then of course you can delete. So views and templates are the next thing that's very interesting about Phoenix, actually. Views and templates are separate. In some other frameworks, they kind of combine them. But really, a view is a module that is responsible for rendering templates. And so it serves as a presentation layer, so you can create helper functions and things like that that will be accessible within the template itself. Templates are actually pre-compiled. So what that means is if you have an HTML template and when at compile time, the view module will then actually have a function named index.html, for instance. And it will have the body, the contents of that function will be the body of that template. And so it's pre-compiled. And so at runtime, you're essentially just doing kind of string concatenation with whatever variables that you have in your assigns. So this is an example of a view where we've got like a title function, which would be a helper that would just take in the model and upcase the title, for instance, which is silly, but it's just an example. And then, of course, you also have things like rendering JSON. So if you have index.json, then you can encode your model into a map, and that model will then be encoded into JSON and is the output. And so you can actually do, like with this one here, index.json calls render many, and you tell it to use the show.json, which would then invoke this and send out an array of post objects. So this is very, very nice to deal with. It's very explicit, so you know exactly what your output's going to be, and it keeps you from shooting yourself in the foot. And so templating for HTML is done with EEX, which stands for Embedded Elixir. And you can embed actual Elixir code in this bracket % equals, which will output the evaluated code. All right, so channels. Channels is really kind of the big deal in Phoenix. It was one of the first things that Chris had actually started when he started Phoenix. And it all came out of the fact that you couldn't really do this very well in Ruby. where you have multiple clients connecting to a server and holding the socket open. It's just incredibly painful and very difficult to do at scale in other languages. And so, channels allow you to route, pub/sub events through a system and do messaging back and forth between the client and the server. So they're very similar to controllers, except for that they're bidirectional. So the server can send a message to the client anytime, and the client can send back to the server as well. And what's really neat about the whole channels thing and the pub/sub is that the abstraction is really nice because you can build different backends for it. It comes out of the box with support for distributed Erlang, which will you can start up new nodes and connect the nodes together, and it will take care of sending messages across nodes, which Chris showed this morning. And you can, of course, build a backend for something else as well. There's a Redis backend, for instance. A lot of people want to deploy to services like Heroku, and Heroku doesn't allow you to do distributed Erlang. You can't connect the nodes together. And so there is a Redis backend that will allow you to kind of circumvent that. So, and of course, Phoenix.js, which is the JavaScript client, which comes out of the box with that. So setting that up, you just, in your endpoint, you have the socket here. And so now with WebSockets, you can connect to that endpoint, and it will start your socket connection. And then you have the user socket, which is where you kind of plug in the transports. Out of the box, we have WebSocket and long polling. And this is where you would also, if you had another transport like Telnet or XMPP or RabbitMQ, you could plug that in here and use a different transport. And this is kind of similar to the router as well. So you have like channel, and then you give it a namespace here. So you have this topic, rooms, and then colon subtopic. And in this case, we have a wildcard with this asterisk, which says, hey, anything that has the topic of rooms, send it to this rooms channel. And the connect function is when you first connect with the client, it's going to come in here. And this is kind of an area where you can do authentication and things like that and make sure that the user is actually able to connect. And if you return OK socket, then you have authenticated clearly and you're good to go. Otherwise, you can return error here and it will decline the user. So the room channel is just a module that you can set up here. You can do pattern matching on the topics as well. So like in this case, we have rooms : lobby. And if it's rooms : lobby, and if we get a message and the socket, then we can set it up here to allow the user to join that topic. You can return OK socket and you're good to go. And then you can also do stuff like this and use pattern matching to match on the subtopic. So we have rooms : and then we're using the binary pattern match operator here. Or I'm sorry, that's string concatenation. But doing the rest of that string there will be the subtopic. And then you could just return error, with a reason, unauthorized, if you don't want anyone to join something else. So then we can also use broadcast, which will then broadcast an event with a payload to all subscribers that are subscribed to this particular topic. And of course, Phoenix.js, we've got setting that up is really, really simple. You just connect on the socket, and then you can set up different handlers and things to respond to different events that come in from that channel. So socket.connect, you can pass in different parameters and things like that into that. This would be where you might pass in like a token or a JWT to verify on the server. And then you set up your socket, or your channel, tell it which channel you want to get in on. And when you're joining, you can actually do some nice kind of pattern matchy Erlang-y things here, which is very clever that Chris came up with. So if you receive ignore, then you probably have like some authentication error or something. If you receive OK and a message, then you're good to go. And then it also has a timeout option too. So after 10,000 milliseconds, then your connection's been interrupted. So you could set up other things on error and when the channel actually closes. You can respond to events like that. And then you can push events to the server. So the interesting thing here from the outside view is that the clients can connect from anything, right? It could be an embedded device, a web browser, or maybe a mobile app, something like that. And then when you need to scale, you can add servers, and all the messaging just travels between the different nodes automatically. So it works great. And then let's say you have a client that connects to the other server. All the messaging is handled no matter what, so it gets transferred between the servers. But from the inside view, when you connect to the server with socket.connect, you get a process. And when you join different channels, you end up getting a single process for each channel. And each channel then holds state for that. And so you end up with a process per channel. So if you have a bug in your code, it doesn't affect the other channels. So if you have the room channel and there's a bug in that particular channel, but you have maybe a user's channel or something like that, then if one crashes, it doesn't affect the others. So that's where that isolation comes in. And of course, they're supervised, so they get restarted and things. And then of course, you've got the pub sub system that has the different backends that you can create, which comes with already support for distributed Erlang and Redis with a separate package. And then there's a package for RabbitMQ. I have aspirations to work with XMPP and Phoenix channels, and so eventually someday I might get around to it when I have time. And I think there's people working on various things like CoApp, which is a protocol that's really great for embedded devices. That's pretty much the gist of it. But really, the thing is that none of this stuff is really all that new, right? We have, MVC kind of request response cycles with many other frameworks. We have, Node.js with, that allows you to write JavaScript to talk back and forth to the server and have these, long-lived connections and things. So what does Phoenix matter in this case? We already have these technologies that allow us to do these. And really it comes down to Erlang. And where you have supervision trees that can restart processes when they die. You've got the amazing concurrency, right? One of the things with Node.js and Ruby is that in multi-threaded environments, it's terrible. You have usually one single thread that you can work with, and with Erlang, everything works across all the cores on your machine. So I think in today's world and in the future, we really have to be using technologies that can take advantage of that. And so I think this is the future of web development. And I think we're really going to start seeing the rest of the communities kind of shifting gears and coming to the Erlang side, because this is really the only technology space that is easy to do concurrency. It's almost too easy. So with that, thank you. Do you have any questions? Yes?
Could you talk very briefly about the migrations model? On a quick look at the docs, it seems as though that lives with Ecto, which I know is not a practice subject.
Yes. So the question is around database migrations and where that lives. So database, all the stuff that has to do with database is in respect to the Ecto library, which is an external dependency. It ships by default with Phoenix. unless you specify that you don't want the database. And so when you generate a new scaffolding, or use like the generators, then a migration file is generated for you, and it will tell in a nice DSL. It will generate some code that will tell the database how to, which fields to create, what table to create, and so forth. And you can do other migrations like adding columns, removing columns, renaming columns, all that kind of stuff.
So it's more. It sounds as though it's more Ruby-like than Django. Like you write the migrations and then you insert a model.
Yes, yeah. The migrations and the model are needed in both, and you also have the model. The model is really just kind of a schema, and it's there to create the struct that will, allow your data structure to exist within your system. And then Ecto is really like, you could spend a week doing a talk on Ecto, and it's really huge, but it's amazing. It's really, really cool. Yeah. Yes?
The JavaScript, was that straight ES6 or is that TypeScript, or what is that file?
Yeah, so in Phoenix, we have on the front end, I'm sorry, the question was about the JavaScript and what form of that is. It's ES6 or ES 2015, whichever one we want to call it now. But yeah, so basically the front end build tools that Phoenix ships with is Brunch, which is a build tool that's really, really simple to configure. Just a few lines of a JavaScript configuration file, and it comes with like Babel and all that kind of stuff to generate the ES6 files, and you can use that all with no work at all. So, yeah.
Includes the shim, like ES6 shim and all that kind of.
Yeah, so the Babel transpiler does all the work. Yeah. Yes.
You mentioned using all the cores on a single resource, say a server, a physical server. One of the good things with Erlang is you don't really program very differently in the case where you have lots of cores across multiple physical machines. What would be the implications of that case in this? Could you do something with more than one machine? Can I lay a server across more than one machine?
So, if I understand the question, it's great that we have the ability to use all cores, but what about distributed across multiple machines?
Yep.
Well, that comes with just Erlang, right? You have access to all the stuff that Erlang provides. So you can spawn functions on other nodes, and you can run tasks that run on other nodes, whatever you want. There's no limitation. Where Phoenix is, it's an application that you include, and it generates code for you to make it very easy, removes a lot of boilerplate, and it provides kind of patterns that allow you to organize your code in certain ways. But it doesn't limit you in any other way. It gives you full access to the VM, and you can do whatever you want. It's pretty awesome. Yes?
What about CSS or preprocessors for CSS?
So with the answer is CSS and preprocessing CSS. That's handled by the Brunch utilities. So there's different node packages that you can download. There's SAS Brunch and other tools that you can use within the Brunch ecosystem. You can also, you don't have to use Brunch either. If you prefer Webpack or something else, you can swap it out. It's not baked in or coupled in any way to Phoenix at all. So it's completely separated. Yes?
This is more just curiosity, but I know Phoenix is sitting on top of Cowboy fundamentally.
Mm-hmm.
Is there any relationship between Phoenix.js and Bullet, or was it that Phoenix.js was created?
I don't know much about Bullet.
I don't know if Bullet's still being updated actually, but it's bidirectional add-on.
Oh, okay. Yeah, so with Cowboy, Cowboy provides WebSocket support automatically within that, and so Phoenix just takes advantage of that. And so the Phoenix.js is just the JavaScript client that connects to the back end and then passes messages back and forth. So, all right. Any others? All right. Thank you.